Hello, welcome to this session today where we're going to talk about model-based testing and the point of view that we have here at Microfocus. My name is Don Jackson. I'm a Chief Technologist here at Microfocus. So today we're going to talk about what is the industry saying about testing tools and practices. Then we're going to take a step back and talk about AI across value stream management, and then drill into a DevOps primer. And all of those three are kind of a background to set us up to talk about model-based testing. What is model-based testing? What are the ideal characteristics of a solution? And what are the benefits and challenges? And then we'll kind of wrap things up. So in December of 2021, Microfocus, my company, commissioned Forrester Consulting to take a look at the state of software testing and quality management practices at enterprises in the financial services, healthcare, and retail sectors. The result is a paper that's called Boost Testing Effectiveness with AI-Infused Tools and Quality Management Practices. And it was based on an online survey of 316 software testing technology decision makers across North America and the United Kingdom. It contained a mix of 226 decision makers whose organizations only use traditional automated testing and or manual testing, and then 90 decision makers whose organizations use AI-infused testing as well. Now, one of the questions was about how happy these respondents were with their traditional testing tools and practices. And it turns out that the answer is really not so much. Only the processes themselves scored over 50%, but less than 50% were happy about the speed of testing, and under 40% were happy with the amount of test automation that they were doing, or the amount of effort to maintain tests. And then it gets worse from there, where we get down to like the 35% mark. So almost 2/3 are not happy with the visibility of their test results and quality status. And even fewer are satisfied with the reusability of their testing assets or the tools that they use for test management and test execution. So clearly, most people are just not happy with their testing tools and practices. So let's talk about at a little bit higher level, AI, artificial intelligence, around value stream management, so across the broader organization. So what is value stream management? So forward-thinking companies are looking to leverage a revolutionary but pragmatic approach called value stream management. Value stream management's roots come from the manufacturing space and are innovatively now being applied to software development and delivery. Now, value stream management is frankly a game changer. It enables organizations to track, analyze, and predict resourcing, waste, risk, and value delivery as a product flows from strategy all the way through delivery. And this is all to achieve superior business outcomes. So today, most companies use a modern, agile, or DevOps approach to software development. And for most of these companies, there's a pragmatic assumption that things will work as planned. So for example, the strategies will be clear. The features will be optimally prioritized, adequate quality and testing will be attained, and that the overall the product that's brought to market will be on target and on budget. Now, most companies employ a range of tools from a diverse set of vendors to support their software development lifecycle. And what they expect is that their value stream might look something like what you see on the screen right now. Unfortunately, the reality is that in spite of this investment and experience, the reality is that the software development is a complex business, and many different factors impact the art and the science of software development. And that could include things like changing market conditions and priorities, inadequate testing, a lack of automation, under-resourced groups, delays in completing products on time, budgets being exceeded, significant redesign and rework, and that leads to the quality being below their targeted standards, and frankly, the overall value creation not being optimally obtained. And so instead of what we saw in the previous slide, what we really see is what you see on the slide now, with a lot of wait time and rework and your key performance indicators, like you see in the lower right-hand corner, showing red or trending negatively. Now, to address these points of friction, I think everyone would agree that there's a new approach that's warranted. And that new approach is called value stream management. Value stream management works by holistically analyzing the software development lifecycle from strategy all the way to delivery. It invokes a new set of value stream metrics, including software development lifecycle efficiency and cycle time, throughput, quality, costs, efficiency, risk exposure, and more key performance indicators. And it does this by integrating with your existing tool chain and related systems of records. And the end result ends up being is that it helps identify where you should focus your efforts, like where you see on the screen, so that your value stream, instead of looking like it does when you first get started, starts to look something more like this. And that result of value stream management is a positive impact across the entire software development lifecycle. Now, when it's done correctly, value stream management can ensure that a company adopts the right strategies, prioritizes the right features, optimizes the use of the limited resources that they have. It maximizes the use of automation when it's appropriate. And all of this leads to eliminating rework and unnecessary handoffs, which in turn leads to delivering superior products. Those superior products cause higher levels of customer satisfaction, which leads to superior business outcomes on a regular basis. Value stream management, or VSM, has the potential to be a real game changer for companies, both large and small. In short, value stream management is really the future of software development and delivery. It complements and integrates with your existing software development and delivery environment to empower you with the insight you need to predict, plan, analyze, and take action to maximize the delivery of value. The result is an ability to deliver superior software solutions for your customers faster and competitive advantages for you personally and for your company. Now, as you see today, you can adapt VSM to your own unique environment and needs and take it at your own pace. For some, that means starting small and expanding over time. And for others, it may mean applying value stream management end-to-end from portfolio management through agile development, continuous quality, and operations, and maybe only doing that on an individual product to start off. So let's take a quick look, though, where artificial intelligence is being applied in this landscape. Now, you've probably heard from us at Microfocus and others talking about functional testing, where we leverage market-leading capabilities around computer vision and natural language processing to make tests more robust and easier to maintain. In performance engineering, AI can be used to figure out what scenarios users frequently use and create realistic performance tests and detect anomalies and analyze performance for tests and even suggest improvements and adjustments to the system to improve performance. In security testing, AI can be harnessed in penetration testing to find vulnerabilities more quickly by figuring out which systems should be tested and determining the best paths to take to highlight weaknesses. For agile planning, AI can be used to assess risk and estimate effort. In quality management, AI can determine which tests to run, the impact of a test. It can identify flaky tests that fail appearingly at random, or oscillating tests that flip between pass and failed, and how to optimize tests and increase test coverage. AI in continuous integration and delivery can help figure out what happened in a build, why it might have failed, and who should fix it, or even in some cases, self-heal, fix it itself. It can make recommendations about what lab machines are best suited to run tests, and how to parallelize test execution so that you can get results as quickly as possible within the constraints of the resources available. Now, looking more broadly, AI can help project and portfolio management teams make decisions across the wider organization. And it can take into account the different individual teams, the different products, and the budgets and those resources. And of course, once we've released a product, AI can help customers to manage support tickets. It can improve the service reliability. It can analyze log files. And it can bring production data back into testing. And it can monitor the system to identify abnormal or even suspicious activities from a security perspective and protect systems from threats. Together, All of this provides input into the entire value stream delivery process, with the potential to surface insights that the team can then use to take decisive action. So we're here to talk about model-based testing. So let's first debunk a myth about testing. Gone are the days of being able to toss the application over the fence to QA once you finish coding. The speed of business is just too fast to allow for the delays introduced through feedback being sent days or even weeks after the developer has finished the code. The human mind has such a challenge context switching from what's currently in the forefront to what was being worked on that long ago. And that delay is further compounded by having to ramp back up on what the developer did prior to committing the code. Now, we in IT, or information technology, we've provided a solution to this, and that's delivering software through a DevOps pipeline. But what is a DevOps pipeline? A DevOps pipeline can be visualized through a water pipeline. There are gates represented by the different valves that you see along the pipeline, and those could be quality gates. And if a failure occurs, represented by the production feedback at the bottom, that feedback is sent back to the submitter, which is usually a developer, and it's sent back immediately. And this reduces the likelihood of those context switching delays we talked about. The submitter then resolves the failure and then resubmits it into the pipeline. When this submission occurs, it should be stored in a source code repository. That source code repository should version the changes, including the submitter comments, and provide collision detection. And the collision is if multiple changes against the same source need to be integrated from multiple submitters, and then merging capabilities to resolve those collisions. Once the source has no collisions, the build system takes over, and that starts executing the pipeline steps. And this is called continuous integration. The first step is to compile the source to create artifacts like a jar file or a war file for Java code, and then to store those artifacts in the artifact repository. Once the artifacts are copied to the artifact repository, and that provides a central location for all of your artifacts, the build system then executes unit tests in the testing system. And this is the first step of continuous testing. Now, assuming that all the unit tests pass, the build system will then engage the provisioning and deployment solution to stand up the next pre-production environment and then deploy those artifacts to that environment. And this is called continuous delivery. Once the environment is up and running the new artifacts, the testing system then executes the appropriate automated tests for that environment, which is another part of continuous testing. The build system then has the provisioning system deprovision the environment, and those last three steps are repeated for each environment or type of testing that needs to be done. That could be things like chaos testing, integration testing, system or performance testing, or other things like that. Now, once all of the testing is completed successfully, the build system has the deployment system move the artifacts into production. And that'll include any steps necessary to have the application start to leverage those new artifacts. This could be as simple as just a Java virtual machine or JVM restart, or maybe even a full system restart, or just maybe even just a cache cleanup or other things like that. Now, if you're doing this, this is called continuous deployment. Now, as part of the deployment, the operations or monitoring artifacts, and those could be scripts, they could be configurations, alerts, other things like that, they should be deployed and activated as well. Now, frankly, they should have been included in the lower environments as well. And if you were doing that, that would be called continuous monitoring. So now that we've set the stage for what is a DevOps pipeline, let's drill into testing, which is what we're here to talk about, and that's specifically model-based testing. So we need to first establish what is model-based testing. Model-based testing is a software testing technique in which the test cases are derived from a model that describes the functional aspect of the artifact or the artifacts under test. This means that rather than relying on the intuition of an individual tester to determine what functionality to test, the business processes themselves that are represented by the model and the underlying individual functions that comprise those models drive what should be tested. Now, typically, the model can, but doesn't necessarily have to be, it can be displayed in a visual format, making it easier to understand what's the business process and what's planned to be tested. Now, I purposely obfuscated the text in here because it's not about the individual details. It's understanding, the flow of the model in a visual representation. Now, we at Microfocus have a viewpoint of the following as being ideal characteristics of a model-based testing solution. So this isn't a comprehensive list, but it should give you an idea of what ideally a model-based testing solution should provide. Now, to be completely forthcoming, to my knowledge, there isn't a single solution anywhere that's available that provides all of these characteristics. But it should give you an idea of what we view as what the future should hold. So first and foremost, a model-based testing solution should enable a component-based architecture to your testing. This means, similar to component-based development, the solution should facilitate the ability to reuse components or units and, frankly, models by other models and users of the solution. Leveraging this reuse is key to increasing efficiency and being able to react and adjust quickly to changes in the artifact or application under test. The solution should also facilitate data being abstracted out of the individual components or units via parameterization and be data sheets that can be fed from your TDM or test data management solution that you should already have in place. Now, if you'd like to know more information about test data management and why it's necessary, especially with all of the privacy laws that are out there, please let us know and we'll set up a separate session for you. Now, like the data, the environments themselves should also be abstracted out and parameterized. This should interface with your lab management solution so that you can data drive what devices, what machines, and what physical and logical environments that you need to execute the testing on or against. This way, when you're driving the solution from your continuous integration solution, you can pass in these values to ensure that you're executing your tests in the correct place and with the correct device or devices. The system should also prompt you for reuse. When you're trying to create a new component or unit, which matches one that already exists in your library, it should prompt you and say, hey, you've already got this, you should be reusing it. Now, once you've named a component or unit, the system should provide a mechanism to underpin that component or unit with different implementation types for the testing. And that should be things like manual steps or UI automation or API automation, performance automation, security tests, or any other type of automated tests. This would also include the metadata that gets tracked as part of the details for that component or unit. And that should include what types of implementation have been created. Did I get a UI automated test out of there? Or a performance test or a security test? And it should also include the status of that individual implementation as well. So is my UI automation in design? Is it being reviewed? Is it ready for execution or obsolete? Or anything else like that? The solution should also provide a path analysis of the completed model with robust, configurable coverage strategies to facilitate the type of testing. So whether you're talking about sanity testing or doing an exhaustive test, or whatever other type of testing that you need to have done on that model, given your current driver for running the test. So your driver could be, what change happened or how much time you have, or how much time it'll take to execute the tests based on previous runs, or what environments are available. The solution should also not just allow for the reuse of an entire model by another model, but it should encourage that reuse via an AI-infused intelligence around the contents of the model and similar flows and those flow locations within other models. Part of that encouragement would be key performance indicators around reuse with industry targets that you should be able to measure against. So who's the best at doing this? What are the best in the industry doing from a reuse perspective, and be able to measure against that? And no matter how you identify your change, whether you're talking about business process change analyzer for SAP, or maybe just interrogating Jenkins builds for code commits, looking for risky code commits, or maybe it's just as simple as build documents. The solution should be able to consume those results, and by leveraging traceability, be able to identify which models are impacted and recommend a coverage strategy with the types of implementations that should be run to eliminate or reduce the risk of what was identified in the change impact analysis results. So for example, if you changed a specific decision point and introduced a security risk, it should flag up anything that uses any model that uses that decision point logic and build you tests for security testing all of those models. The solution should allow you to underpin the component or unit with any automation tool that you choose for each of the implementation type, providing that that tool allows for a command line interface execution of the script and outputs the results into a standard format, which is right now, the standard in the industry is a XUnit, JUnit, NUnit type format. But it should be flexible to change that format if we change in the industry what's the standard format in the future. And lastly, but not necessarily least of which, each abstraction layer, so the components and units, the data sheets, the environment sets, the models, all those other things, they should be under version control, including versioning, branching, collision identification, and merging capabilities. So I always find that pictures, frankly, help us understand concepts. The old adage of a picture paints 1,000 words. So I thought it'd be helpful to lay out how a model-based testing solution would work from the abstract all the way down to the specific. Now first, you start in the design realm. You should be leveraging any BPMN or business process modeling notation process models that you already have in place, plus any existing automation tests, and that should give you a head start to building your model and component and unit library. The BPMN models should be imported or reused to build out the process models. Then you can overlay the nodes in the model with automated assets that you've imported as well. And now, once you've done that, the users can review each model and underpin each node with the appropriate implementation artifact. Now, once you have the model ready, you then transition into the path analysis, where each path or flow through the model is laid out for the user based on the coverage strategy that you've specified for that model. And that should be driven by your current needs, like we talked about earlier. You then get a list of paths that cover your model, and you choose for which ones you want to create tests. And when you start the create process, you then start to transition into the execution realm. The solution should then create all of the tests that will be available for execution that represent the paths or the flows that you have selected. And these tests should be injected with the test data from your TDM or test data management solution, and you're now ready to execute by your continuous integration tool. The continuous integration tool then executes the tests, providing results back to the tests, which then in turn provide coverage information through the backlog item covered. When a change occurs that changes the model, you start the process over, analyzing the paths using the appropriate coverage strategies, generating new tests, and then executing those tests. This is different than, and is vastly different than what people think about testing today, in that the tests themselves are actually disposable assets. It's really the model that drives what gets tested in conjunction with your coverage strategy for that model. This is a radical change for most testers or test engineers. So now let's talk about the benefits and challenges of model-based testing. Now, frankly, I like to talk about challenges first because I'm the type of person who wants to get the worst over with, and then I focus on the best. So for example, when eating my food, I eat my vegetables first. Now, utilizing model-based testing techniques requires that everyone who's doing testing should work with the same approach to testing. You have to have everyone on the same page as to what constitutes the demarcation line of a component or unit in a model. And you also need to make sure that everyone understands the different coverage strategies available to you and their impacts and when to use each. Now, frankly, this is an OCM or organizational change management challenge that should be mitigated through proper OCM practices, those being things like training and mentoring and auditing. And as alluded to previously, this is a pretty radical change in thinking. Not only do you have to understand model-based testing, you also have to deal with the OCM challenge of changing the way you think about what assets are the key assets and which are disposable. This can be further complicated by regulators or auditors who may not understand that the model is now the key asset. You may have to educate them as well. And the last major challenge that I see is that you need to have an intimate understanding of the business processes. Now, frankly, this can be mitigated through leveraging existing business process models that have been developed by other folk in your organization, or by sitting with the business owners to understand how the business is run through your application or applications. But now let's talk about the benefits of a model-based testing approach. And the first one is reuse. The reuse of artifacts not only significantly reduces the amount of time it takes to build tests. When something changes in the business process or application, you only have to make that change in a single place. And that exponentially improves the time it takes to adopt changes. Now, I've personally experienced, and I've seen in many organizations, where the automation team reaches a point where they can't create any new automation assets because they spend all of their time adjusting the existing assets due to changes in the business process and the applications. Now, reuse significantly reduces those impacts. Another big benefit is that it extends the reach of testing to your non-technical resources. With the ability to abstract out the underpinning of each implementation type, of each component and unit, plus with the injection of AI, so computer vision combined with natural language processing and the capabilities, those capabilities into the model-based testing, now your non-technical people can contribute not only to defining the business processes that you need to test, but they can contribute to automation of those assets as well. We could have another session of AI-infused testing and our market-leading capabilities of our Codeless, and our AI-infused automation solutions, but we're going to keep focused on model-based testing for now. Now, with proper coverage strategies, you can reduce the number of test cases that you have to execute in order to maintain proper coverage of the business processes being tested. Because you're reducing the number of tests that you have to execute, you're also reducing the execution time for testing the model, because you're able to execute a minimal, streamlined number of tests. The system should be helping you achieve proper coverage with less runs. And since the system is now understanding the relationships, those upstream, downstream, and cross-stream relationships of the components and units and models, and you're tracing them back to the backlog items, which in turn trace to the code in your application, you now don't have to rely on a person's intuition to determine what is directly and harder, and more importantly, frequently, indirectly impacted by a commit made in an application. The system can prompt you on what needs to be tested. And with your coverage strategies in place, you can generate the proper tests to cover them with the appropriate amount of coverage for the backlog items and their associated changes. Additionally, we've had customers already talk about how leveraging model-based testing has exposed areas of their AUT or artifact under test that they hadn't planned to test originally. But by exposing the upstream, downstream, and cross-stream impacts, they realized that they've been missing some key functional areas as part of their current tests. And with all of the reduction in time, plus the relationship coverage, this actually aligns better with the faster pace of change that Agile and DevOps practices bring into an organization. And for all of you automation folk out there, this can help you determine what should be automated and in which order. If you're able to know that a component or unit was reused 100 times through all of the models that you have, it's probably a prime candidate for being automated and should have a high focus. If a component or unit isn't reused at all, it might not be a good candidate for automation. Now, obviously, there are other factors involved in determining what to automate and when. But having empirical evidence like this to help facilitate that decision making is something that should be welcomed by any automation team. Now, here's a video on utilizing coverage strategies. So this is a simple model that I created for our demo application called Advantage Online Shopping, or AOS. Essentially, you can do a product search to determine when you're not logged in. Or you can choose then to log in, or you can stop. Now, once you've logged in, You can clear the cart, search for a product, add it to your cart, or you could abandon and log off. Or if you add it to your cart, then you could check out and then log off. Now, this is a very simple representation of an e-commerce model. Now that we've got the model, we can set up our coverage strategy. First, let's look at the full coverage strategy, where we want to make sure we hit every branch through every decision point. For this very simple model, you can see we have 5 possible paths through the model. Now, if we change the coverage strategy to be a sanity test, now we only have to run through 2 paths to sufficiently test our model. Each node is hit, but not every branch of every decision point. Now, of course, you can modify settings to customize this as well. Maybe you have a specific point that you need to test all of those branches because the change that was made was in that specific decision point. So you need to do more robust testing there. Or maybe you have the converse happen, where you're dealing with a new application and you have to avoid a specific node because that part of the application hasn't been built yet. The point is that you can focus your testing and you can streamline how to adequately test based on your current needs. So now let's talk about where we at Microfocus stand when it comes to model-based testing. So we at Microfocus, as Mercury Interactive, actually launched one of the first model-based testing solutions called BPT, or Business Process Testing, in September of 2004. That product is still in use today and has many customers who leverage it and get value from it. Now, in February of 2022, we introduced our new value stream management platform called Value Edge. As part of that launch, we launched within the Value Edge functional test section a new solution called model-based testing, or MBT. And in the video that I showed and the screenshots, I used that as the application to provide examples. This solution also includes 2 licenses of our newly launched AI codeless testing solution, which is a truly codeless solution rather than a code suppressed solution like some of our competitors. The AI codeless testing solution, which was provided as a technical preview previously to UFT1 customers, is part of our Shift Right solution stack, extending testing and test automation to non-technical users. So here's a screenshot of what an AI codeless testing script looks like inside of MBT. As you can see, the quote-unquote script is in near plain English. No user should be scared off by something that says click the profile or type the value from the datasheet for @user_ID into the username input, or click the sign-in button. And then this is what the script looks like in the AI codeless editor. It's a simple, easy to use solution that allows non-technical people to now contribute to automation. If you'd like more information, please reach out to your local account executive and we'll be happy to come in and show you these new solutions. Now let's circle back to the satisfaction slide that we talked about at the beginning. Model-based testing actually addresses every single one of these points, and it should help you move the needle to increase your organization's satisfaction with your testing tools and practices. And with that, I want to thank you for taking the time today to listen to us on our point of view around model-based testing. I'm including a QR code here and a hyperlink for an ebook on integrating open source and COTS, or commercially available off-the-shelf software. Thanks again and have a great rest of your day.